Hello everyone. So today we are going to solve and do the questions as well as the topics that are remaining in the chapter called Dual Nature of Matter and Radiation. So today what we are going to do is photoelectric effect. So first one, let us understand what is photoelectric effect. Okay. So this is the second topic of our chapter after the de Broglie's wavelength. Okay, de Broglie's hypothesis. 你哪个？这堂是题要不做 photoelectric effect. Photoelectric effect. Now, what is photoelectric effect? So I just want all of you to write with me. So photoelectric effect means it is the phenomenon of spontaneous emission of electrons. Okay, spontaneous emission of electrons from the surface of metals when light, you can say, when light, which is a radiation of suitable frequency, okay, suitable frequency is incident on it. Okay, now photoelectric effect basically means it is the phenomenon of spontaneous emission of electrons from the surface of metals when light or radiation of suitable frequency, mark these words, that is suitable frequency, is incident on it. Now let us understand what it means. Okay, and this comes under the experimental setup. Okay, the experimental setup of photoelectric effect. Okay, within this, what we have a basic circuit. Battery trigger. Okay, this is a battery. This is the key which is closed. Now in this circuit, this is the negative terminal and this is the positive terminal. And at the negative side, this is the negative side and this is the positive side. This is negative side, so it is called cathode. Okay. Cathode side la, metal plate. Okay. The definition then I want to so diagram so suppose this is the metal plate which is at the negative terminal, which is your cathode, and in this side like collector. Okay, positive means this is the anode side. Okay, and here you have the collector. Why I am calling this collector, you will know in some minutes. The collector and this side this side of the collector and this side okay, this side of the emitter. Okay, this side is called emitter and this side is called collector. Now this setup is within a vacuum tube. Okay, this is a vacuum tube. Now what happens? There is an opening here. Okay, here is some way from which radiations are incident on the metal. Okay, radiation suppose from the sun. Okay, now these radiation I have said that the radiation the energy jigyola. So radiation the energy, that is your E, is written as h nu, further written as hc upon lambda. Okay, this is your Planck's constant. Let's say. So digamos the energy incident on the surface of metal. Okay, this is the metal plate. Now electrons will be released, and this is called photoelectric effect. Suitable frequency level. So suitable frequency means here the frequency of incident radiation, that is nu, should be greater than nu naught. Okay. Now here nu is what? Nu is the incident frequency of the radiation that we are talking about. Okay. Now also the radiation on the photon you are thinking okay. So photon is nothing but the particles of light. So particles of light collide. One photon will collide with one electron, and one electron will be released. The electron so electron photon electron so ray of light. Suppose this is a ray of light. So ray of light will consist of millions of photons. So each photon will collide with one electron on the surface. Okay, superficial electrons which are loosely bound. Collide and electrons. Okay, electrons. Now electrons are negatively charged, so they will be attracted by this positive charge. Since this side the electron collect, that's why it is called the collector side. Now since electron the collect has a circuit, now electron flow and it goes in this manner. Now electron and this side of flow current direction this side the current flow, that is your current I. Current I will flow in this direction. In this way, an additional current, okay, an additional current is set up in this particular circuit. Now next topic, so the in this way. Okay. Now next topic is some important terms. Some important terms. Okay. Now, in some important terms, the first term is threshold frequency. Okay, and this is represented by nu. Okay, second term which is your work function. Represented by phi naught. Okay. Third one is your threshold. Threshold wavelength. Okay, threshold wavelength represented by lambda naught. And fourth one, which is quite important, is your stopping potential. Okay, the fourth one is stopping potential. Okay, stopping potential represented by V naught or sometimes Vs. Okay. Now, stopping potential. Okay, so let me add just one term here. Fourth, intensity of light. Okay, intensity of light I dash. Okay. Now, threshold frequency it is the minimum frequency of incident radiation below which there is no photoelectric effect. Photoelectric effect has to do minimum frequency go incident light the frequency threshold frequency okay, threshold frequency, and threshold frequency value the nature that depends. So it means that different metals will have different values of threshold frequency. Okay. That work function frequency minimum frequency the threshold frequency the minimum energy of incident radiation Okay, that is your phi naught. Phi naught is equal to h nu naught. You have what's your formula there? Is equal to hc by lambda naught. This formula. How was it? The minimum energy below which there is no photoelectric effect is work function. No, now threshold wavelength. Now threshold wavelength is the wavelength of incident radiation. That the minimum time one, because in this formula we can say that nu is inversely proportional to lambda. Now nu the maximum lana and also the lambda the nu the minimum ina lambda the maximum na also nu lana also khala minimum frequency threshold frequency. Now minimum frequency threshold wavelength the maximum wavelength of incident radiation. Okay, mark my words, the maximum wavelength of incident radiation above which there is no photoelectric effect. Okay, mangtha lagoya wavelength the mungtha lagoya. So in a shadow example but you just have to know the formula. Numericals also linked. This is also the video ki end la, so numerical is also. Now fourth one is your stopping potential. Now stopping potential is na color karte. Now the exam na maupo de so ngai the color pani dictate chu kunchu tik cha. So start writing. Stopping potential na dire. It is the minimum negative potential. Okay, it is the minimum negative potential which is set up. Okay, so since stopping means to stop, so stopping means to stop. Electrons now electrons they are catching by this collector side since it is positive. Now stop charge you have to change the polarity of this particular battery. Positive side they side the reaction such that there are positive plate and there are negative plate. Now there are negative plate, there are certain values in the wall potential. Okay, the main the electrons path has a negative repel the chile, but at certain value of V. So the it is the minimum negative potential, okay, set up at the collector side below which, or you can say for which photoelectric effect is stopped or ceased. Minimum negative potential at the collector side for which the photoelectric effect is ceased or stopped. Now, intensity of light. The intensity is the color. In the previous videos, diagrammatic ray of light photon. So photon the energy. Ray of light there are infinite number of photons. Like you see, there are metal plates here. So metal plates photons. Now photons, so the energy here, and each photon have energy which is equal to h nu or h c by lambda. Now photon the energy, okay, per unit area. Area is the incident the area per unit area per unit time. Okay, photon energy per unit area per unit time. Now intensity of light. Okay, photon the energy per unit time. Per unit time and per unit area intensity of light. And exam unit okay, in exams the unit is quite often asked. Now unit can cut here energy per unit joule. Energy per unit area inverse per second and time. Joule per area inverse means area unit meter there, so joule per meter square. Okay, per unit time means second inverse 1, or you can write joule divided by meter square second, meter square second. So this is the unit that we are talking about. Okay, and this is quite important because it has been asked. intensity equation and stopping potential equation D is another layer for 1 mass. Okay. Now stopping potential also is cut off voltage and layer. Okay. Sometimes also stopping potential cut off voltage layer. Okay. Okay. Now then some important graphs. Okay. Important graphs. Now important graphs point Einstein's photoelectric equation. Einstein's photoelectric equation kinetic energy max of photoelectrons time kinetic energy max. Energy minus phi naught. Or you can write kinetic energy max is equal to h nu minus mu naught. Further equal to, you can say h nu minus phi naught. And this is equation mahu jaan. So then kinetic energy design electrons ki kinetic energy, which is the remaining energy after phi naught is consumed. Phi naught ki energy di consumed chasana hama the kinetic energy. Kinetic energy yena shini electrons emit chede ma to sheba kinetic mane. Okay. So then kinetic energy okay, max surface video okay. Now kinetic energy directly proportional nu you can write it as the kinetic energy of emitted photoelectrons are directly proportional to the frequency of incident radiation. Frequency of incident radiation incident radiation की frequency पर kinetic energy now number of photoelectrons electrons emitted. Okay, number of photoelectrons is directly proportional to intensity. Intensity is now basically the number of photoelectrons electrons की थाम जो electrons देख यहाँ की intensity intensity is number of photon energy or you can say photon energy पाना क्या है photon की number so number पाना photons की number पाना photoelectrons so the outcome number of photoelectrons is directly proportional to intensity and kinetic energy max is directly proportional to nu. So this is quite important. The photoelectric effect is a spontaneous and spontaneous instantaneous. Light power electrons turn to Kc nu naught and energy of instantaneous work function of the given metal okay. Now important graphs. Important graphs important graphs should be number of photoelectrons emitted, or you can say current. Photoelectrons theoretically the current so the current light the current so number of photoelectrons theoretically I intensity so they need to graph somewhat like this. Their graph will be somewhat like this. I already said that I is directly proportional to I dash, like the number of photoelectrons is directly proportional to intensity. Number of photoelectrons is current. Now current the I directly proportional to okay. So directly proportional in a graph a straight graph. Yeah, saturation current because at some point of time there are electrons declouding in the vacuum tube. Vacuum tube na electrons decloud the electrons delay no more electrons can be released. This needs to at some point of time saturation current lagu. Okay, this is the case. Nibadila the graph between kinetic energy, you can write this as well. Graphs between kinetic energy, graph equation of this situation. Okay, this graph is quite important. Okay. Now, in this graph, we have to find the relationship between kinetic energy max and the incident frequency. Okay, frequency of incident light. Take understand. Just see this graph. Formula. The formula is kinetic energy max is equal to h nu minus phi naught. Kinetic energy max is equal to h nu minus phi naught. Consider this as equation number 1. Okay, mainly let's say kinetic energy max now. Frequency is directly proportional. So obviously straight graph straight line in a straight line so they continue how y is equal to mx plus c. They can be equivalent so okay. Now this is your equation of straight line. Okay, this is your equation of straight line. Now y is equal to mx plus cd. Equate. Okay, if you equate this with this particular equation, okay, equation equation y is what the kinetic energy to. Now nu the x axis kana the x now compare to h. Okay, comparing equation number 1 and 2, also the so m, which is your slope. Okay, m is the slope slope is equal to h that's what slope is equal to h. Intercept y intercept minus phi naught. Then plus minus plus 0 so c and c intercept the minus phi naught. Intercept minus phi naught. Now intercept the point at which the graph will intersect the y-axis. Y-axis kana intersect chidu graph. So y-axis to set the point the negative phi naught. So this side the positive, origin ki gaun sama positive, or the negative. So intercept phi naught is negative wave ki divide intersect. So dirani straight line expression. Okay, so the point is intercept, that is your phi naught minus phi naught. That this side the point the threshold frequency because threshold frequency mara photoelectric victim data line imaginary. Okay, now this side photoelectric effect so this is your new node. Okay, so graph the formula the graph this is your theta and slope slope tan theta there. So here slope kinetic energy max versus delta nu W. Okay, delta nu W. So these can be slope m is equal to tan theta. Theta gives formula tan theta. Now formula d through tan theta h. Now the equation through tan theta so tan theta means proper brushing perpendicular upon base. Perpendicular is delta kinetic energy max upon delta nu is equal to h. Last one. Now the equation in this scenario delta kyangi E change combination and delta EVS in this energy. Okay, delta H is equal to H. Because also how would you say kinetic energy the formula D can charge into yes stopping potential. So in this way we can find the value of H. There is an for 3 marks. Okay, 3 marks on the question they do. Okay. So this is how you derive this particular graph. Graph is quite important. Graph chipu 1 mark na is the yam na the derivation 3 marks na is the. Okay. Now Diram graph okay. Not just some of the knowledge to okay. I just want to give all of your homework. Kya ke heights here sim there are heights kinetic energy versus okay. So now it is of okay, so then kinetic energy versus new graph says what? I just want all of you to find the graph between stopping potential, okay, stopping potential versus new graph. Okay, stopping potential versus new graph. Stop the angle okay, main thing graph is stop the angle. Okay, but I just want all of you to write in the comment box. Comment box में क्या कहे थी नहीं? Graph क्या नांगे है? Graph सबटा नांगे है? दिनांक जुड़ी है. सबटा दी दो जुड़ी graph दी. इन्हें मां क्या ना जवाब है कोई दी केस ना ला slope दी h ला सो. चिकवा चिंगा क्या ना intercept दी minus pi not plus. तो दी केस ना ला क्या ना m की value करे. चिकवा चिंगा क्या ना the c की value करे. दी नहीं क्या ना से दी okay, what is the value of slope here? Delta slope h delta slope है delta slope की value minus pi not delta slope की value है sorry intercept की value है okay, do the same procedure same way, okay, you will get your answer. Okay, with that I will end this video. Don't forget to like, share and subscribe my channel. Okay, good day.